reduction formula continues, and this time we're considering n is a definite integral. Now we develop the reduction formula, start considering the by parts, right? We consider 1 over this is u, dv is dx. So this one is equal to uv v times u minus v du x, v is x, du is the derivative of this with respect to x, right? Minus x minus 1. Then the chain rule. Okay, that is my VDU. This one is equal to 1 over 2 to the n minus 4, and the negative n taking out becomes positive n, 4n. Then you have a 1 plus x fourth, negative n minus 1 times x fourth, plus 1 and minus 1. So this one is equal to 1 over 2 to the n plus 4n. This one time that one is this. 1 plus x to the 4 to the n, right? dx. Minus this one time this one is this. N plus 1 dx. So this one is equal to 1 over 2 to the n plus 4n. This is my I sub n. This one is my I n minus plus 1. Yeah. So this side is I sub n. So we find the reduction formula 4n times n plus 1. Right, move over there. This is 2 to the n plus 4n minus 1 times in. Yeah, this is my reduction formula. Yeah, for this integral. Well, I0 is x from 0 to 1, so it's equal to 1. But we cannot find I1 from this. Well, when we're looking for I1, so n must be 0. When n equal to 0, this is 0, right? So this formula, it's valid only for that. N is a positive 2 or more. So how do we find the others? We must find the special value of I1. Okay, let me discuss this one a little later. Here, I want considering another method of developing this reduction formula, which means that we integrate this one using another method. So the other method is it's worthwhile showing here. It's a very good way to integrate like this. Now, now I consider this integral. No, consider this derivative rather x over 1 plus x fourth to the power of n. We consider this derivative with respect to x. So I'm using product rule. I consider this one times 1 over that. So it becomes this plus the derivative of plus x times this one, right? This derivative times this plus x times this derivative, x times this derivative, right? Excuse me my messy writings here. Okay, that's the product rule. So this one is equal to 1 over 1 plus x fourth to the power of n plus x times this derivative. That derivative is equal to negative n to the power to the this derivative times 4x cubed. Well, good. Now this one is equal to 1 over 1 plus x fourth to the power of n, and minus 4n. And a 1 plus x fourth to the n plus 1. And this is x fourth. And the plus 1 minus 1. Yeah. So that one is equal to 1 over x fourth to the n minus 4n. This over that is 1 over x fourth n, right? Minus this over that one is 1 over x. Yeah. Good. So this is equal to that. Then we integrate both sides from 0 to 1. That is, this integral is equal to antiderivative, right? 1 plus x fourth to the n. This integral from 0 to 1 is this. And then this side is integrating. This integral is my I. This integral is my given minus 4n. This integral is in minus this integral from 0 to 1 is my in plus 1. So this side is equal to 2 to the n is equal to I. Now I combine this one. It's 1 minus 4 n plus 4. Yeah, so this 4 n plus 1 is equal to, we move over there to the n becomes plus 4n minus 1 to the in. Wow. So we get the same reduction formula, just using different methods. It's worthwhile, to show there are two ways to develop this reduction formula. Okay, that's good. Now Then, as I said, this formula is good for n equal to 2 or more. For I0 is very easy. We can do it is equal to 1. I1 is this. I1 is I1 is this. We cannot find this I1 from reduction formula because it doesn't work. So this is a special value we have to work out. Now I have a video showing this indefinite integral. I don't want to repeat here. There are quite many steps. You can go see it. The link is below. Okay. There are two methods to do this integral. So I just use the result. This result is 1 over 4 root 2 natural log x squared plus 1 x squared minus root 2x plus 1 plus x squared minus root 2x. Then from 0 to 1, okay? This integral is not that easy. There's quite many steps. So I suggest that you go see my video now to get this result by using two methods. Then by substituting 1 there and then minus 0 there, we get the value approximately 0.861. That is my I1. Then we can find other values from the reduction formula. Okay, I want to show the examples for I2 and I3. Okay, for I2. Now, this one, I2, when n equal to 1, n equal to 1. So, for I2 is equal to 1 over, here I'm using n equal to 1, right? That's 2 plus 4n minus 1, n equal to 1. So is equal to 3 I1. Yeah, it's correct. So this is equal to 0.5 plus 3 times 0.86. Now that's approximation. Okay. Then this is equal to 3.101. So this is my 4I2. So I2 is equal to 3.101 divided by 4 is equal to 0.777. Yeah, this is my I2. I2 is dx over 1 plus x fourth square integral from 0 to 1. Now, okay, for I3, this is the integral. I forget right integral. This here, 1 plus x fourth, 3. Yeah. This is my I. This is my I2, right? This is I2. I better write it 1 plus x fourth squared. Now, for this one, I'm using the reduction formula here. So I set n equal to 2, right? N equal 2 for n equal 2. So the formula says that 8 I3 n equal to 1 is equal to 1 over 4 plus 2 times 4 is 8. 8 minus 1 I2. Yeah, I'm sorry. This is the reduction formula. When n equal 2, I get this. So I get it I3, So 8 I3 is equal to 0.25 plus 7 times I2. I2 is this. So this approximation, this is 0.25 plus 5.439. So I3 is could be found, right? Yeah, it's 5.689. X equal to, well, the calculation is less significant. The reduction formula is more important. So this one is approximately equal to is approximately equal to 0.7127. It's a great, very nice. Okay, I've done a dozen examples of reduction formulas. I think it's quite enough. You can, well, you once you know the principle, you can do yourself, for many other reduction formulas and their applications. Thank you.